The room is full, and therefore we can start 3 minutes early. That buys us a little time because I have a very full program. Good morning, everybody. My name is Clemens Fastas. I'm technical lead at Microsoft. I work on the Windows Azure App Fabric Service Bus team, and I'm going to talk about the new capabilities that we have in Service Bus and that we just released into production. And in the course of that, I'm also going to have some interesting news and surprises, maybe even. We're also going to show you some demos that I didn't write, but that were written by someone else. We're going to go talk about that. And because we don't have a lot of time, usually the sessions are 75 minutes. This time it's 60, so therefore we're going to jump straight into the topic. So Service Bus is an infrastructure that sits up in Windows Azure. And the way you can think about Service Bus is a federation infrastructure. What that is for is that you can have applications that sit in the cloud and and other parts of applications that sit on-premise, and we allow you to take endpoints or message sources or message consumers and federate them through the cloud. We call this hybrid applications. So we have an infrastructure for connectivity, we have an infrastructure for messaging, and we're going to be talking about those. We will be building out our capabilities around service management over time and also around integration. You're going to hear about those things within the next 6 months. And before this release, before we just rolled out the new capabilities into production, actually not on Tuesday, but last week, we were mostly a connectivity service. So connectivity meaning we have a service relay that allows you to build all kinds of capabilities. We have, you can build protocol tunneling capabilities on top of this. There's samples out there. It does direct eventing and also will enable other capabilities over time. So that's a picture that I've been showing for everybody who's been following Service Bus around for the longest time. So for everybody who's uninitiated about this, we have in WCF integrated programming model, and we're using only outbound connections, so the receiver really is hooked up to the relay. So the way you can see Service Bus working in your mind is we have the same relationship between a listener on Service Bus as a listener on the local machine has to HTTP sys. We have a web service. The web service listens on HTTP sys in the way that it effectively parks a subscription in the kernel and gives the kernel a callback. And as soon as something shows up on the HTTP channel that the lease is for, the kernel calls back and then delivers the event stream. So just like that, we have in Service Bus a naming fabric where you can go and on your namespace, go and lease part of that namespace for your listener. As soon as a request shows up at that place, we're going to give that to you, but we're going to give that to you through a connection that you have established through our API to us. Outbound connections default to TCP, ports 9350 through 9353. If those are not open on the firewall, we switch over automatically and we use port 80. So we establish outbound connection dual streams over HTTP. And some interesting additional benefits that gives you, except that you can listen on from any machine, is that we are acting for you as a DMZ, as a demilitarized zone, and we guard those services using the access control service. So to make that a little more tangible for the people who haven't seen that yet, I'll go and show you that. So here's a sample from our SDK. You can find that in the SDK, the path. Let's go on what the path is. It's in the samples directory under exploring features, relay messaging, bindings, web HTTP. That's where you can find that exact sample. So I'm going to run it. And what that sample does is it puts up a local WCF REST endpoint, right, on this machine that's exposing an image. But you now have a public internet endpoint. So if you have one of your wonderful devices and you actually have network, if you go to tinyurl.com/getimage, let me do that here. Tinyurl getimage, because I have that shortened. What's going to happen is you're going to see that picture. of the early Microsoft founders. Now, this came from a public internet address. It comes from the data center, but the data center actually negotiates a socket into this machine, which just sits here on the conference network. I didn't talk to anybody. I'm not cheating. So you can create an endpoint from any machine, from any networking environment, and just make it work. So you can do HTTP over this, you can do TCP over this, you can do a lot of things for direct messaging. That is something we have been shipping since January 2010 as a commercial offering, the relay. Let me close that down. I don't want to close all tabs. I'm going to tell you later what that is. So that's a fairly amazing capability all by itself. What we're now adding, and this is what we did last week, is we now rolled out a brand new set of capabilities, and that's what I'm going to focus on. Let me say something about that rollout. What we did last week is, proverbially, we took a fully decked out table with all the china and crystal and silverware on it, pulled the tablecloth out, and put a new tablecloth in, and nothing moved. We changed the entire architecture of Service Bus underneath the running system, and nobody was interrupted. So that's a thing it's interesting in terms of building services, something that we learn about building services for Windows Azure because we built on top of the platform. And these are all things you're going to get over time, and you already have some of those capabilities available for building continuous, always available services. Service downtime doesn't exist in our vocabulary. And if you build Windows Azure services, or if you build cloud services, it shouldn't exist in yours as an A-side. So let's talk about messaging, first in the abstract, and then we're going to take a look at an example, and then we're going to guide you through how you can actually leverage those capabilities. So the thing I showed you just before, the REST sample, goes through an intermediary that we call the relay. So you have a sender, the sender routes to a receiver, and that has the same characteristics as a TCP connection. So all the things that you have on the Service Bus relay, so everything that runs through our DEPCF bindings that we have in the system, exhibits the same characteristics as TCP, including things like back pressure, which means if the receiver doesn't process the messages, there's back pressure into the relay and back pressure from the relay into TCP, so we're keeping effectively the same TCP characteristics intact. So that's direct, what we call relayed messaging or direct messaging. In brokered messaging, so that's the new capability, there's a broker in the middle that is actually, first of all, manipulating the messages. In the most minimal way, it goes and puts a stamp on the messages in which order they were received, so it assigns sequence IDs. So if you have many, many concurrent senders, there is order that's being enforced by labeling them through an authority, and that authority is the broker. So that's the first difference. The second difference is the broker has storage. So the broker can store, for the various messaging constructs, 1 gig, up to 5 gig of data, and buffer that up. So what you get with this is decoupling of the sender side and the receive side. The model of communication is also different between the two. One is push, in the sense that if the sender sends something, through the intermediary, the receiver will get a message without specifically asking for that message. In the broker case, the sender sends a message, and the receiver will only get a message if it specifically asks for that message. So it really, when you start thinking about this on the wire, it is merely a pattern difference. So there's grand discussions that people have about push versus pull and polling and long polling and what is what. In the end, it's really the difference between push and pull, or the difference between push and polling, is a pattern difference. It's a difference between sending one message and receiving any number of messages in return, that's push, or sending one message, specifying how many messages you want, and get exactly those messages in return. That's pull. So the pull model is something that's new for us in Service Bus. So there's 3 ways to pull. The first is receive and delete. Receive and delete, you get a message, the message gets transferred, and as the message gets put on the wire, we delete the message straight away. That's very fast, but the message can be lost if the connection crashes. So if you don't need to have assurances about those messages, you just need to get them through the system fast, and it's okay to lose a message, and it's not lose a message in the UDP way, where you throw something at the wall and then 3 messages come out of 300, but it's really only if you lose that connection. So if you can live with that, that's a good option. Peak lock is another mode to get messages. The way how that works is you walk up to, as the client, you walk up to the broker and you say, I want to have the next message, but keep it and put a lock on it. Hide it from everybody else. So you get that message, you get a chance to process it. If you're able to process it, you walk back and you say, thank you. You can remove the lock and throw the message away. Or if you say explicitly abandon, sorry, I couldn't process it, the message reappears in the broker. If you crash, that will happen too because there's a timeout associated with that lock, which means as soon as the timeout expires, the message shows up again. And then there's transactional pull, which allows you to do the pulling in the scope of a transaction. You pull and you pull and you pull. It behaves like receive and delete effectively, but then there's magic that is in the client that will allow you to do that within the scope of a transaction so that you don't complete the individual messages or abandon individual messages, but you rather go and complete a complete transaction, and that will go and take a whole batch of messages, like let's say you received 15, and make them reappear in the queue if you couldn't process all 15 of them. The messages in the brokered model, and that's something that's also not really specific to Service Bus, but it's true for around across a range of brokered messaging products, are somewhat different from messages if you're familiar with the SOAP model, or even with HTTP, which is often very centric around the entity body. It's somewhat different. We have a key value pair structure called properties, and we have a body that's in that message. In messaging, it's very common to just use the key value pairs, even to go and express business values, and use the body in not as often as you would do that in SOAP. There's actually good reasons for that that I'm going to show you later. So don't think of that as a SOAP message. It's closer to the HTTP message, in fact. So if you think about a brokered message is actually a good container for a SOAP message that would flow in the body. But you will want to take some data out of that SOAP message and promote it out into that property bag. And I'll give you some reasons why you want to do that a little later. There are 2 entities, 2 major entities we have in the system. And they're really expression of patterns on top of a common infrastructure. The first pattern is a queue. And the queue is a prime factor of data structures. So it's logical for us to have one, specifically because we're in a messaging infrastructure. So what is it? It's a sequential log. There's a broker that stamps messages, so it judges on timely arrival and on order. You can have competing consumers, which means you can have multiple people, multiple programs pulling on that queue. So first pulls, second pulls, and the messages get distributed. And then there is one shared cursor, a thing that scrolls over that log and says what the next message is, and a shared set of logs over that log. The other pattern is the topic. And a topic is also a sequential message log, so from the front it looks exactly like a queue. From the back, it kind of has multiple heads. It's the hydra of messaging structures. It's got multiple subscribers over the log, and each of them has its own set of cursors and logs. So you create this sequence, and now you have a subscription, and each subscription can go and scroll forward over that log, and also has a set of cursors. What that yields is a wonderful way to put one message in and have multiple subscribers go and look at at the message log independently, so that every subscriber has a chance to get that message. On a queue, you have one shared cursor, everybody moves forward together. In this model, everybody can have their own cursor, so they move out and everybody has a chance to see the same message. So those topics are a really interesting concept to build applications. With that, I would like to invite David Bedin from Bedin Shop Systems in Italy, who will show you how he's using topics in a real production system.
Okay. So good morning, everyone. My name is Davide Bedin. I'm the CTO of Bedin Shop Systems. And for the next few minutes, I will talk about how we use service bus topics in a kite. So a kite is a point of sale and an in-store software as a service designed entirely for the Windows Azure platform. The kite retail web services in the cloud save and analyze data while connecting the stores with the retailer headquarters and with any external web service. The two smart clients, Post.net for front store operations and Shop.net for backstore tasks, work disconnected and cooperate in a peer-to-peer way. Therefore, no server is needed in the store, as it is a single point of failure and one of the most underutilized pieces of hardware. And this represents a big chance for retailers to reduce energy consumption. A kite removes all the complexity from the store, making life simpler for retailers, also from an economic point of view, as there are no investments, just an all-inclusive per seat per store fee. And a kite has been live on Windows Azure with paying customers since the worldwide launch of the platform in February 2010. So the Kite Smart Client relies on a local embedded database to work disconnected and as a cache. Therefore, synchronization between these clients and the web service is one of the most important scenarios in a kite. And we decided it was the right place to introduce service bus topics as it could have the greatest impact. This is how the refreshed architecture works. So here we have a backstore client running in the headquarters, sending a request to the web services. The update is performed on the tenant database, and events are recorded in the event store. The client then receives a response back. In the meanwhile, the synchronization worker role is looking for new events to process. It finds the just recorded ones and composes the information gathered from the tenant database in a way it can be consumed by other clients and place it in Azure storage. At this point, the synchronization worker role is ready to send messages to the service bus topics to notify the events. Each one of the Kite Smart Client has its own subscription to the synchronization topic, and each subscription has a set of rules that ensure each client receives only the notification it is interested to. So here in this example, the Kite Smart Client in a store received notification that new updates are available and cooperate together in order to have just one of them to get the updates from Azure storage and then make it available to other clients over the faster local network. So now it is time for a short demo, and I will show you how a retailer can perform a price update across a chain of store so we can experience the synchronization scenario in real time. I'm going to work on a chain of store we use for demonstration that is running together with many other real tenants in the production environment of a kite. So here we have a lot of things on screen. I have 3 different stores, each one with the Post.net client, the front store, active. And let's check the price of the Coke Light, for example, here in Los Angeles. So here we have the New York City store. And in New York City and in Los Angeles store, I customized the surface to place product for rapid selection. I didn't do the same in the London store, so I had to browse product category to get the same product. So now it is time to go back to the backstore client, Shop.net, running in the headquarters. And here I'm going to perform 2 updates. I'm going to do a price increase on the sale prices for the US price list, and this change will apply to the US stores only. And secondly, I will change the description of a product, and the expectation of this change, as I'm going to change the English description, is that it will apply to each one of the stores that I show you. So quickly, I will change the sale prices, and I would like you to note that the Coke Light has the same price we just saw in Los Angeles. And even more quickly, I will change the description of this product, so making the classic Coke the new Coke. So synchronization in a small chain of store is simple, but having many chains of moderate complexity, or maybe synchronization already started, or having a chain with a large number of stores and several clients in each store do represent a challenge to the synchronization of events. Okay, let's keep synchronization happening. So a kite assists the retailer in preparing information well in advance. For example, sale prices can be updated but activated on a later date. Nevertheless, wanted updates are sent to and received by every client in the same and shortest period of time. And situations may arise in which you need to react quickly, even if you have hundreds of clients to update all at once. So if we take a look here, we should see that if you manage to see the different messages popping up in the virtual machines and the host machine, the updates that has been received by different clients are different. So the London store just received one update because we changed the description, and London store is not interested in the price list for the valid in the US. So the classic Coke became the new Coke. While in Los Angeles and New York City, they received the price update, so Coke Light now increased. And we also can see that the classic Coke became new Coke here too. So this scenario can be approached even in a more classic way. And that means having potentially a good number of clients pulling a web service for updates. The downside of this approach is that it consumes the resources of your Azure application, while Service Bus is technically far more efficient than this and can relieve your application from this job. So the change we applied to this scenario really simplified the architecture. As we do not have to intensively pull a web service for updates, we heavily reduced the load on web roles as well as on SQL Azure. We saved about 60% of the web service calls. And what is really interesting from a strategic point of view is that the whole synchronization scenario is now supported by the platform. That means Windows, Azure, and Service Bus. And as a result of this change, the Kite Retail Web Service can now focus only on the business relevant functions. So in the end, a Kite is now able to scale even better than before. So the Bedin Shop System, the company that makes a Kite, is based in Cornuda, a small town in the northeast of Italy, halfway between Venice and the Dolomites. And this is a picture of our town and where our office is located. Okay, so I wanted to show you this picture at the end, not to reinforce the idea that every corner of Italy is nice, which obviously I think it is, but to show how Windows Azure lets you create and run a multi-tenant, multinational service application from wherever you are. And what is really important to us about Service Bus is that it brings client applications close to you as the developer in a way that was not really possible before. So that's all for my part of the presentation. Thank you for your attention, and thanks to my team.
Good job. We went live last week, and they're live on Service Bus already. So that's great. So David has been one of our TAP partners in the TAP program and has given us great input for the scenario and to improve those things. So we've been listening to customers like Ben and Shop Systems. We've been listening to the community on changes. So if you have already followed us through the CTP that we released in May, you've probably interacted with the SDK and with the bits. So what I'm going to do now is I'm going to show you some snippets, some code snippets, and show you how Bedin and other people have been interacting with Service Bus and point out some changes that we made based on customer feedback. What you'll find is that the model, if you have been interacting with Service Bus in the CTP phase, that we've streamlined the API a little bit and made it a lot better to use for everybody who's exposed to this for the first time. I hope you like that too. So, messaging Service Bus, how does that look? The hello world is, I know the hello worlds here at this conference look a little funkier, right? They're all in XAML and HTML and JavaScript, so ours is a little more boring. We have, so let me go line by line. We have a new construct called the token provider that replaces the secrets, shared secrets. I'm going to have more on that later, where you can find out more about that entire architecture. For now, it's sufficient to say the token provider is a thing that holds a credential, and then as you give it to the system, whenever the system needs to have a token from the access control service, it goes to the token provider and gets one. The reason why we introduced that new notion of token provider is very simple. You can build your own. So if you wanted to build a way to do federation via access control with, let's say, Facebook, and you need to pop a dialog, right? You need to pop a window that holds the web browser control, do the Facebook login, and then steal that token out of the browser window and then use that. You can now do this because we made the token provider extensible, which it wasn't before. The next thing is just creating a service URI. You can also create them directly. What this will do is create an URI called SB, and then myNS, and then servicebus.windows.net. That's all it does. So it basically takes out the ceremony of creating those URIs in the correct way. And then you go and create the namespace manager. Service Bus has that namespace where you can go and place stuff in. So you get namespace manager, you put the service URI in, you take the token provider in, and then you create a queue. So that's how you go and manage you create a queue in the system. Those queues are now persistent, and there's a delete the queue. We're going to see all those things. Then there's a messaging factory, and the messaging factory dispenses are objects that allow you to interact with those objects. We're going to see that too in detail. And then you can create a queue client, and on the queue client you can now go and send a message. And then you can also, of course, from the queue client receive, and then also get at the properties from the message that you received. So that's the hello world, the simplest, shortest program to write from and to service bus. It's not a lot of lines, really. So let's go into more detail on those things. So the namespace manager. Namespace manager is a new class used to be called in the previous CTP service bus namespace client. There was a lot of stuff to type, so we made that a little shorter. So you create a namespace manager. That's the same line as before. You can now test whether the queue exists. That was an obvious one. So check whether the queue exists and then create the queue. Check whether a topic exists and create the topic. You can go and delete the queue. And then you can create topics. And then you can go and create subscriptions, all from that namespace manager. The namespace manager is really the thing that lets you go to the service bus namespace and just create things. The way you imagine the service bus namespace, really, for people who haven't interacted with the system yet, is like a directory structure, but where all the names that could ever exist already exist. And with the namespace manager, you basically go and place things into that namespace infrastructure. So the queue name here could very well be /A/B/C, and then you can go put things in parallel. However you want to go and manage that namespace and structure it is really up to you. For now, you can only create messaging entities with this, but it's a service bus shared thing. So in the not too distant future, you'll also be able to create relay points, pre-declare relay points using that mechanism for some features we have planned for the future. The messaging factory is the specific factory that dispenses objects for interacting with the messaging infrastructure. For the relay infrastructure, we have channel factories, and then we have service hosts, and we have all those WCF constructs. So we're using the WCF program model. For this, we have introduced a new programming model just for the messaging infrastructure. But there is a programming model for WCF. I think I have a slide about that too, which allows you to just have a net messaging binding that sits on top of this entire infrastructure. So if you're a WCF developer and you only want to shuttle SOAP messages around, you can stay at the WCF level and just use that, and that's exactly equivalent functionally to the net MSMQ binding. Well, not exactly equivalent, but largely equivalent to the net MSMQ binding if you're interacting with local queues. So you get symmetry out of that. If you're, thank you. I said there are some differences because MSMQ doesn't have topics, right? But for basic interaction, sending messages, receiving messages, you're going to get the same experience out of it. And you can take an existing app that uses WCF against MSMQ, and largely, in the most cases, just make it work across and against Service Bus. So for Windows Azure, so for Windows Server applications that you have today and that are using MSMQ, to move those off into Windows Azure, you now have effectively a complete replacement for that infrastructure, which you can't stand up in Windows Azure, and that's a big thing. The brokered message, and then, of course, I should go back once. So from that messaging factory, you can create a queue client. You can create senders. So there was a concept that you always had to create a sender in the CTP, so they now made that go away. You can still have a sender. The difference between the queue client and the topic client and the sender is that the sender is really abstract, which means it doesn't care whether it's a queue or a topic. So if you use senders and if you use receivers, your application can be agnostic to whether it sends to a topic or to a queue, or whether it receives from a queue or from a subscription. So you create those objects, and the function of the messaging factory is also that it creates a scope for connections. One of the things that we've done, and that's a huge amount of work that went into the guts of this thing, is we changed the connection protocol in pretty dramatic ways between the CTP and now, and the messaging factory is a scope for connectivity. So the messaging factory, everything that's created as clients out of the messaging factory shares one connection. So if you want to have multiple connections, you can have that, but they all are multiplexed. Everything is multiplexed on that one connection. It also now has automatic reconnect logic, which it didn't have before. So we're taking all the magic that we have in the relay and apply that here. So if you go and receive a message, let's go and look at this from the receive here, the subscription client. If you send the receive message and you say, I want to have one message, and the connection ruptures, we reestablish that connection. We still know that you have one receive outstanding, so we're not going to fault that immediately. The objects dispensed by this no longer fault. So you don't have to go and reestablish them. They no longer fault. Create messages, also new and improved, because now brokered message has a proper constructor. That doesn't seem like a big thing, but if you're working with a bunch of Java heads, that turns out into a fight. Sorry to the people at home. So the new brokered message now has a proper constructor which allows you to do this magic. You can go and simply use the facilities that are in C# and just set all the properties in one single place, including the system properties, time to live and reply to, and then the custom properties that you have in your app, and simply make that a one very small and clear expression, which actually looks a little more cluttery if you don't have that factory. The downside of that is if we now wanted to create magic messages, well, then we have to give you an extra class because we no longer can hide that in the factory. But that's a usability compromise that we made that's hopefully useful. What we also have is a way to go and take any serializable object, data contract serializable object, and basically just stick that into the message. What happens then is the message gets the object gets serialized and put into the message using the .NET binary XML encoding. So it comes out as application/msbin1. Because that's the most compact form. So it gets data contract serialized and gets put into the message as that binary format. So that's good for .NET to .NET. What you can also do is you can go and put any stream in. So you can take some text, write that into a stream, UTF encoded. You can go and set it to text plain. It can be JSON. It can be anything. And what that gives you is a way to go and shuttle arbitrary content through. And since the queues and the topics have a REST interface, you can have a REST interface on one side, and you can use the .NET API on the other side, and go and send payloads that are interoperable between those. What payload you send is completely up to you. It can be anything. So we have a very simple way to go and use the data contract serializer. If you want to use a different serializer, you can do that. There's an extra parameter that allows you to do that too. Sending messages, you do with the queue client or the topic client, or as I said, the neutral sender. So create a client, go send. That's it. There's also the asynchronous method, begin send and end send. If that hasn't become clear yet at this conference, right? Section 2 is your future. Asynchronous is your future. Embrace it. Embrace it. So I'll give you a little story, background story for Service Bus. We went through the system for everything that we do. So we do, underneath this, we do sockets and we do HTTP and we do all those things. We changed our system from having a couple of blocking things. Well, a couple in a large system is more than two. Blocking calls that we had in the system, and we made the system categorically everything is async. Our capacity for a stamp of service bus, that's kind of a deployment, a unit of deployment that we have, we could go from 96 VMs to 50 just because of that code change with the same capacity. That's how much different async makes, because you're sticking to the I/O threads, and this is why we're also exposing iasync result, because that's the straight mapping into I/O threads. So we're actually in sync with all that I/O completion port threading. So you should use async whenever you can, because while in UI technologies that you've heard a lot about, async is mostly about sharing one thread between all kinds of different components. Here it's about sharing one operating system kernel thread between all kinds of components that are doing I/O. As soon as you have some blocking object, you lose that advantage, and you get context switching and churn and all those things. So async is the thing you should always do. So send is pretty and short, but the efficient thing is actually to do the async calls. Receiving messages, as I said, there's two ways. The first one is the destructive read, where you can receive messages and remove them immediately. The way you do that is you create the queue client with the receive and delete option. Then you receive the message. As that message comes out, that message is already gone from the broker. So if you fumble it and drop it on the floor at that point, message gone. Another thing that's noteworthy is the try receive. Here's something that we found interesting. During the keynote, there was the second day keynote, there was this wonderful sample that they typed up, and they said, oh, we're going to use try receive. That try receive we actually cut out. So they were going against the labs version. So the receive now, we changed that. So there was receive and try receive. What that receive now does is, if there's nothing coming after a minute, we'll just give you a null back. Because you tend to want to do try receive. And the reason why you tend to want to do try receive is because you want to have canceling loops. So the time span, the receive time span you can put in there is time span max value. Right? You can wait forever. And as long as you wait, we're going to go and reconnect, and we're going to honor that request because the broker is just memorizing that. And we'll memorize that for as long as it can. However, the practical thing is to go and receive for a minute or two, because you will want in your app to be able to abort your loop, right? And again, this is the synchronous version. The begin, receive, end receive does the same thing, so it will also have that pending, but that receive will now be managed kind of by the kernel, right? Because we're passing that down into our infrastructure, which ends up being just kernel weights. And then as a message shows up or no message shows up, you're getting called back. For receive, for send, I would be forgiving and say, if you do the occasional blocking send, that's fine. A blocking receive in our team would never pass code review. We're giving you that option because we're nice people, but you shouldn't use it. For simple things. So receiving messages with pclock, similar model, code looks almost the same. I have the receive mode pclock. Now, I receive the message, I wait for it. If the message is not null, then I'm trying to do some work. If processing the work fails, I abandon the message, which means, sorry, here broker, you can have your message back, give it to someone else. or I complete the work, which means I'm done with it, and then the broker can go and delete it. The same thing is done kind of under the covers in Magic if you use the transactional mode. Also, it doesn't need to be a transaction. It doesn't need to be an exception, obviously, right? You can lose work or declare work bad for all kinds of reasons. So you may just abandon messages for some other reasons. There's another talk which is about advanced topics, which is this talk is really a prequel to a video I already recorded last week, which is the advanced session, and you're going to be able to find that on Channel 9 tomorrow, which is going into more options that you have there, including dead lettering that message. So there's a special dead letter queue where you can stash messages that you open, you look into that message, and your process decides that's garbage, but you want to have a place where you can safely store them. You can go and dead letter them, and then there's a way to go get that dead letter queue and then pull them out. So that's a facility that you can also use here. So using those queues, you get some really interesting characteristics and some nice patterns that you can use. The first one is load leveling. If you have a website or some other service and you get a lot of load into your service, that is often, if you're doing everything synchronously, which means you have a web service that's HTTP, and then that's calling another web service internally that's HTTP, so kind of the pressure comes out from the back from the customer straight down into the system. You need to scale the whole system up to that exact need. If you put a queue in front, or if you put queues in the middle, what happens is you now get kind of a funnel that can take your jobs and reduce the stress on the system. So if you get spiky traffic in, and a lot of systems get that, where you have kind of on the hour, on the half hour, even per day, sort of spiky periods during the day, but you really don't need to process that data in microseconds. That's actually helpful to have a queue there because it levels the load over time. You don't need to have as much backend capacity as you would need otherwise. The other thing that's really nice is that you can have different lifetimes between those objects, right? You can have the sender can send it to the queue, the receiver may be offline, or it may be intentionally not there. I talked to some customers yesterday about a scenario where they just do end-of-day processing, right? Work comes in during the day, and they say, I don't want to stand up my worker roles in Windows Azure for the whole day because they're just doing work for an hour. Why should I do that? So one of the things you can do is take a Windows Azure project, the CS package, use the management API, right? And then have some other role that is doing something else or something that is on-premise, and go and deploy at 6, right? Have it available at 6:10, let that go and drain the queue, and then it goes away, right? That's possible. You can really make it as dynamic and simply not have a job sitting in the data center if you don't need it. And that's an offline scenario that is equivalent to the good old batch processing, right? Batch processing is, if you have capacity, you just go and make it available. And with the tooling that you have for Windows Azure, also with the APIs, you can do things that are that dynamic because you have a system that allows that. And because we have capabilities that are somewhat too much to explain right now, that allow you to go through to create transactional like processing on the way. The other thing you get is through competing consumers is you get wonderful load balancing. So you can send messages into the queue, and then you can have multiple receivers which each get messages off that queue. And that's true for the queue, as also true for subscriptions. So you can have any number of receivers, and they're all competing for work, and you get load balancing across those. You can combine this with ASP.NET in wonderful ways by using correlation. That's another subject that I have in the extended session on Channel 9. Topics are the other capabilities. And if you want to think about queues, are really a degenerated small version of a topic, right? They are a topic with a single subscription that takes all messages, and you can pull on it on the end. So that forms a queue. So queue is A topic, as I explained earlier, is a log, and you can have multiple subscriptions over it. The way you manage that is create a namespace manager, create a topic, and then you can create subscriptions on that topic using that path, and then add filters to them. So those filters matter and are important, and the way those operate is over the property bag. So remember what I said about the messages? The messages have these key value pairs. You can create SQL92 expressions over these key value pairs and now go and filter messages out. So you can basically just wish what you're going to get. So I have 4 subscriptions here. The first one is the audit subscription. That is the single biggest advantage over queues, because you can always have an extra tab that just sits there and that you can get messages out of. There's 2 versions of that. There's an audit subscription, which categorically gets all messages, and you go occasionally and drain them, so you get the raw data, and you can use it for all kinds of reasons, diagnostics or really supervision of what the business is, and you can always add another subscription. So there's a good reason to use topics instead of queues as a matter of course in the business system. The second thing is a blind tab. The blind tab is a subscription that already exists, but it has a false filter. The false filter basically says, I don't want to have any messages. But you can go into that subscription and edit it at runtime and change the rules, change that filter condition on the fly, so you can go and effectively go and get specific messages out. So you start out with this blind tab, and then you can go and edit the properties. And then you have specific subscriptions for instance, the ship country, if you want to go and splice off, if you want to do partitioning. And then down here, if you want to go and create a subscription that has more options, there's a ton of options that you can go and set. You would go and create the subscription providing explicitly a subscription description. If you use the REST-style API, so all of these things are all available through REST. And we're going to make implementations available for Silverlight and a bunch of other languages that are just sitting on top of that REST API in addition to the .NET client, which has it all conveniently in one assembly. So that's all backed by a full RESTful API. Receiving messages from the topic, now you have a subscription. Receiving messages is exactly the same as on the queue. So you create a receiver or a subscription client, and then you receive, and the semantics are exactly the same. Transactions work the same, peak lock works the same, receiving the lead works the same. So it's exactly symmetric. The tail of a queue and the topic, the tail of the topic, so to speak, are exactly identical, also on the REST protocol. And the heads of a subscription and the head of a queue are also identical on the protocol level and also on the programming side. And that's why you can have that receiver, and the receiver can be agnostic to whether it's a subscription or a queue. The filters have the simple SQL92 syntax. The way you think about this is really, it's like a SQL where condition clause, but we don't have any functions yet. So there's no functions that allow you to go and slice a string or do any of those things. But there are simple conditions that fulfill a lot of needs. So one of them, for instance, is you can do partitioning. Last name like v%. That gets you everybody who sent all the messages that have a last name property that starts with v. So that's really useful if you want to do partitioning using a topic. A topic is good for broadcast, right? Everybody gets the same message. Or you can have mutually exclusive rules across all partitions, and with that do partitioning via the topic. And the nice thing there is you can go and completely rearrange the way how the partitioning works by just reconfiguring the subscriptions without affecting the publisher in any way. So it's a nice decoupling of send and receive side. Each filter that you set can be associated with a filter action where you can actually set a new property or manipulate a property. So you can have multiple those rules on the same subscription. So you can say, if you're waiting for a specific message with a specific message ID, you can go and set a rule and say, message ID equals this text. It's just a string, right? And then you can add another rule, and another rule, and another rule, each waiting for specific messages. And you're only going to get messages with those specific IDs, but all of them match to a single topic. if you want to have a signal of which of these filters hit, you can do that by just setting that condition. Oh, and whenever you have a match, each match is yielding a copy of that message with the condition setting. If you have two filter conditions and two filter conditions both match, you get 2 copies of the message, with each with the thing set. So why topics? Obviously because message distribution, and you get partitioning. And topics can be done with in really interesting use cases. So I have one, and a friend of mine has built something for me. I got to go and log in back to my machine here. A while ago, a few weeks ago, and her name is Kelly Summers, also known as Calabyte on Twitter, rockstar in Windows Phone and mobile programming. So she has helped me put something together. So that's one of the first demos that I'm demonstrating that I didn't write. But it's very simple, and it's just showing very nicely what topics can also be used for. So obviously, since Kelly is a mobile developer, if you thought you would get away from XAML here, no chance. So I'm going to go and start the same app on my phone. I don't have any of the funky devices here, but of course I'm fumbling. So I'm going to go into the same app, continuous client. So you notice the little button that says play. So I'm just on oops, that was a little fast. I'm just on the normal T-Mobile 3G here, so I'm not on the network. So I'm just completely disconnected from the rest of the world except here. And I hope I have connection. Who believed that I wouldn't check that before? And there we go. So it takes a little time. And the amazing thing is, Kelly built a so-called continuous client demo. What is a continuous client? A client is a continuous client is where you can have multiple screens, in this case 3, and they're actually getting synchronized. So I can go and stop all of those guys, stopped, by clicking any of those screens. Think of the possibilities. So the video here comes from storage, right? But what happens is I coordinate the work across all those clients using across all those clients, I coordinate that work through Service Bus. And what also happens is that the streams are encoded for the different targets. So I'm not pulling the video out, I'm just synchronizing them up. And you can go to any of those clients. Now, it's called continuous client, and I have actually had to cut some things out just because of bandwidth constraints. It's called continuous client because you can go and watch the movie on here, right, in the full built-out version of this, and then you can go and go to the server-like client and go exactly where you were. It'll go and continue. So think of the wonderfulness you can do with that on video, right? You can watch a movie with the family on screen, and then if you need to go and step out to get everybody a drink, you can take that movie with you, right, and not miss a minute. But obviously, in tons of environments, it's fantastic. You can go and take the application state and effectively replicate it in real time between all kinds of apps, and it works cross-platform. So that's a fantastic demo, and Kelly's going to look on, is going to watch the video. So thank you, Kelly. So let me, before I switch completely away from it, let me go and just show you how that's done. There's an event bus that's in here, the event aggregator. The core piece that so as soon as you click the button, it's going into her event aggregator. So she's creating a play message. That play message then gets serialized. She's using kind of our Silverlight API. And then, so this is how the messages are emitted. This is how the messages are handled. So this is how it goes back into the UI. And then there's this event aggregator, and that thing goes and connects up the service bus. It goes and requests a token. Once that token is requested, she goes and hooks up to the subscription. That's a different programming model, slightly different programming model that she's using in her demo because she's sitting on top of the REST API with her own abstractions. And then she's starting to receive a message, and that's how all the clients, the Serverlite client as well as the phone clients, are getting their messages, and that's how it's synchronized. And every single one of them has another subscription. There's a version of that also for iOS that she wrote. So there's a video on YouTube that Kelly put out, which is actually showing also the iPhone doing the same trick, so you can go and check that out. So that's a really interesting way of thinking about Service Bus, not from a hard business messaging perspective, but really about synchronizing experiences. And that's a really interesting thing for, guess what? The operating system that I shall not name. So, I wish I was kidding. So lastly, what I'm going to do is I'm going to give you a quick tour through the SDK samples. I'm actually just going to show you two. And I'm going to switch back. Where am I? Right here. So in the samples, you will find a number of, so you can go and download them from the SDK download site in the download center. There's a package you can get, and that's all the C# samples, which are kind of illustrating all the things that I just showed you. So I'm not going to run any of those, but you can go through those, and let me give you a quick insight into what we have there. So I copied them into a directory that I had. So these are the samples, the C# ones. And we have 400% was a little much, my friend. People here are not that blind. Hey, good. Oh, it's not letting me. Look at that. So we have exploring features. So first of all, we have getting started. Brokered messaging, relayed messaging. So that's the relay, that's brokered messaging. And we have exploring features. There's an authorization sample. That is in the the other talk that I have, that I'm going to have online tomorrow. And there's a number of brokered messaging features, brokered messaging samples that are there that you can go and try out. So let me go back to this normal state. So summary. Messaging, brand new set of capabilities, reliable message transfer, all kinds of wonderfulness, two extra sessions. But I have one more thing. Codename Iguazu. Codename Iguazu is something you will not expect out of Service Bus. What we're doing in Service Bus, and we've talked about this to MVPs, and what we want to give you, I have a minute and a half left. I'm going to go over by one. I want to give you just a little glimpse of something that we're going to do in the future, and I just want to get your reaction to it. Iguazu is a service that allows you to get data from all kinds of sources, notification sources, that may be RSS feeds, that may be Atom feeds, that may be OData feeds, that may be email accounts, that may be Twitter, that may be Facebook. It's going to take that data from all those sources, it's going to normalize it, and then you can go and create some applications for all sorts of different platforms, and then you can go and subscribe to those events. And the system is automatically going to flow all of those. So to show that, just one platform, I'm going to go and load this. And I have a little mobile app here. I actually have a number of mobile apps on my phone that are using this system, and I can go and deploy this to my emulator. And the application is a simple RSS reader. So let me go and start this. So this is reading the MSNBC headlines. Now, we can't rely, since I'm using real-life data for this, I can't show you that in real time, so I modified that program. Whenever something happens on MSNBC on that feed, you get a toast notification. So we're going to go and try to simulate that. So I'm going to go and turn the toast notifications on. I'm going to go back out. And instead of listening on the RSS feed, in this case, I'm actually listening on a queue. So you can, of course, listen to Service Bus topics and queues. So I'm going to go and send one message with the title in here. I'm going to send that message through Iguazu, through the system, and there's a notification showing up here, and also the notification showing up on my phone because it's also subscribed. The interesting thing here is, if you have 100,000 subscribers, that'll work too. If you have 1 million subscribers to that same message, that'll work too. So Iguazu gives you a broadcast notification capabilities into phones, into web browsers. Oh, let's go and look at the web browser. So messages that have arrived, right? Same thing that I'm listening on. I'm going to show you showing those up. I'm just going to show you the code for that. That is the code. So what the system gives you is, this is a tiny jQuery extension, that's all you need to get an event, and that's actually showing up as a JSON object on your side. On the phone, on iPad, on Android, to subscribe, you need to have a single post, and that post allows you to take the raw events that come out of the RSS feed, out of OData, and map them specifically into the title that you want, or into the alert body that you want on Android. You can control the sound. You can go and control what page you want to go and navigate to. And so you can go and map all those things. So we have an acquisition system. We have a distribution system. This distribution system is going to go and push. So what we need to make this real is that you like it. So if there was any question of what a technical lead does, a technical lead sits down for 8 weeks and just writes that. And so I've been working with a number of folks of trying things out. That was the first time we've shown that in public. And so we're actually looking forward to have some people, and I'm going to be over at the exhibition hall. If that sparks ideas, come talk to us. And it's currently fairly rough, so without parental guidance, it's kind of hard. And for any future activities that are going to happen here, we'll also probably need to take you into a special program. But if you're interested in this and have ideas for how you can leverage a system like that can take a message out and push that to 100,000. And by the way, you can also push the service bus, right? The thing that I just showed you, that REST service. I have an app that sits on my desktop that listens through the relay on HTTP, and the system can go and push to it. So this also pushes HTTP. So if you're interested in that, talk to me in the convention hall or come to the Ask the Experts, and I'm going to go and help you with that. So if you want more, if you don't have enough of Service Bus yet, 2 sessions come online tomorrow in Channel 9 as this session is posted. I call them 162A and 162B. The first is Advanced Patterns and Guidance, and the second is a long-awaited, long-missing session on how to do access control on Service Bus with fine-grained access control. You can set ACLs and all those things, and there's actually a sample inside of the SDK that lets you do all those things, and also a tool, a command line tool that actually lets you secure this, and in the session, I explain you exactly how that works. With that, thank you very much. Have a good rest of build.